Hello friends, in last session we talk about the data structure, particularly non-linear data structure, a tree. So we have defined the a tree, then we go for the binary tree and then binary search tree. If you just recap for the binary tree and binary search tree, the similarity between the binary tree and binary search tree is that each node is having at most two children. But when you go for the binary search tree, how the binary search tree is going to be constructed? The first node will be at the root, whereas all other nodes are added as per the its value. Means whenever we want to add the new node, we are going to check whether the value of that node is less than a root node. If it is less than, we put it into the left subtree. If it is greater than or equal, we can put it into the right subtree. So here we assume that we either have a tree or binary tree with you. We have particularly binary tree or binary search tree with you. Just as in this example, we will find this is the binary tree which is with you. So this is the assumption that we have a binary tree with you. Now, one of the primary operations that we are going to perform on a binary tree or binary search tree is the a traversal. Just as we have seen previously, what is meant by traversal? Traversal is nothing but what? To visit each and every node of a tree. In the terms of linked list, which we have previously learned, the traversing a linked list is a process of visiting every node of a linked list. So in a similar fashion, for a binary tree or binary search tree, we say that the traversing a tree is a process of visiting every node of a tree exactly once. Means from where we are going to start? We are going to start from this root. Okay, so for this root, we have the two subtrees are there. What we have? Two subtrees are there. This is your left tree or left subtree, and this is your right subtree. What we have? We have the left subtree and we have the right subtree is there. Now, there we may have the different combinations are there to visit this one. So the first combination that we are going to find out, just as for a sake of simplicity, what is the first combination that we can find out? We are going to find out is that first we are going to visit the root and then visit left subtree and right subtree. This is the first one. Or second one, we say that first visit the left subtree and then visit the root and right subtree. Or third one, we can first visit the left subtree and then right subtree and at the end we are going to visit the root. So if you are going to check for this one, what is the first thing says that visit the root? Means where you are visiting first? We are first visiting to the node. Which is the node that we are going to visit? We are going to visit the root node. Followed by root node, what we do? We are going to visit the left subtree. Means we are going to visit the left subtree. Now what the process that we are going to apply to visit the left subtree? Again the same process. Again the same process that we are going to apply. So we are doing this one in which manner? A recursive manner. What the way that we are going to apply? We are going to apply the recursive way to visit the each and every node of your tree. So what the first thing is that visit the root and then visit the left subtree. After finishing the all the node in the left subtree, not a single node. We are not going to say as the left a child. We are going to say it as the left subtree. So after visiting a left subtree, we are visiting the right subtree. So this is the one combination that we can get. What the second combination, it says that visit the left subtree first, means we are going first all this one. So when we are going this one, means we have started from this P1, this root node. Then we are coming from its left subtree. Whether this left subtree, this is the cube is the root one. Whether where we are going, we are again going to its left subtree because it is not a empty one, not a null one. So we are visiting, so left subtree. So we can go, this is a say to be a depth. What we are going to find out, we are going to go via its a depth. And that's why this recursive traversal is also says to be a depth traversal also. Okay, so we have the first way, it says that first visit the root, then visit the left subtree, means a left subtree, again we are going to visit the its left subtree. Now, unless and until the left child is not empty one, we are going to process this one. Means first we can visit for P, then we can go for the Q, then we can go for the I. So when we are going for the I, we can check that whether its left subtree is empty. Yes. When we can go for the right subtree, unless and until the left subtree is not finishing, so we are not going for the right subtree. So here we have the three combinations that we can find out for a traversing a tree, and based on this traversal, we may have to say that we have the traversal that is called as the a pre-order traversal, in order traversal, and last one is the post-order traversal. Based on these three combinations, what we can get, we have the three types of traversal that we can have. In a pre-order traversal, first we are going to visit the root. Now this pre-order traversal, we can consider it is nothing but a simplest thing as the prefix expression. So just as for example, I will create a simple tree. So this is my plus sign is there, and for this plus sign is at root, and it has the two childs are there, A and B. What we have, it has the two childs are there. So what the pre-order traversal says, that pre-order traversal first say that visit the root. Now when you are visiting a root, means you are processing the data at that node. Now here the data is nothing but as the plus sign, and processing a data means what the operation that we are doing. Here we can say